Hi, everybody. Today we're going to be talking about graphs with asymptotes. So a mathematical, clear, and complete definition of an asymptote requires some idea from calculus, but some examples of graphs with asymptotes might help you recognize them when they occur. In the following examples, the dotted lines are asymptotes and their equations are given. In the two lower graphs, the y-axis and x equals 0 is also an asymptote. So they give you a lot of examples. The ones like this one, and this one are not things you're going to be seeing throughout most of your high school mathematics courses, okay? Mostly you're going to see this and exponential equations. So this and exponentials is kind of the most we do. Occasionally we do some trig stuff, but that's about it. So you're not really going to see these very often. Okay, but they do tell you a lot about what asymptotes are. So when we look at this, what we can see is, oh man, this is our function. So our function is these solid lines, and our asymptotes are these dashed lines, okay? And the dashed lines are just trying to describe to you the behavior of the function. This function is going to get really, 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 really close to this dashed line, but never touch it. And that's what these dashed lines are explaining. They're explaining that this function is going to get really, really close to these dashed lines, but not touch it, okay? So that's what they're trying to explain. We're going to go over this very lightly in this course, but you will get more information on this as you go along, especially in Algebra 2 and then later in Calculus. All right, so as you can see, the examples above, they can be diagonals, curves. However, in this course, they will almost always be horizontal or vertical lines. And I can guarantee that they will always be. So in this course, they're always going to be horizontal or vertical lines. So let's first talk about the case of having horizontal ones. So a horizontal asymptote is just like this one right here, okay? And it means as the function stretches to the right and the left, so you have to consider in your mind, if this function were to keep going this way, so towards the negative and positive x directions, that means this line is going to get closer and closer and closer to this dashed line and never touch. When you look at it on a graph, you're going to look at it and it's going to look like it's going to touch because it's trying to get closer and closer and closer to it. So it's going to look like they're going to touch, but they're actually infinitely close to each other, but not touching, okay? So that's a horizontal asymptote. Vertical asymptote, same idea, but in the vertical direction, obviously. So it means as our graph here gets closer to this value is at x equals 2, by the way. So as we start approaching x equals 2 from the right and from the left, we see that, oh man, our function here is getting closer and closer to this dashed line, but it's not touching it, okay? So it's gonna look like it's gonna touch it, but it's actually just getting really, 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 really close to it, but not touching it, okay? So I know that in this one, our function does seem to touch this dashed line. It's because this is describing that this graph is getting closer and closer to it, but not actually going to settle here at any point. But for our purposes, asymptotes don't get crossed by our functions, okay? So they will never, never touch those dashed lines. Okay, let's specifically talk about it with exponentials though, because that's really what we're in it for, okay? So when you look at these, I want you to think about those percentage problems we did earlier. So really out in front here is a 1, our initial value. And we're saying we're going to multiply 1 by 1/2 repeatedly, just like in our sequences. So our initial value is 1. We're going to multiply it by 1/2 x amount of times, okay? I want us to think about that. So let's consider what would happen if we have 1/2, which again really is 1 times 1/2, to the 0th power. Now we know anything to the 0th power is 1. So if I have 1/2 to the 1st power, that means I'm taking 1 and I'm going to multiply it by 1/2. 1 times 1/2 is 1/2. 1/2 to the 2nd power, well, that means I'm going to multiply it by 1/2 again. 1/2 times 1/2 is 1/4. All right. I'm going to go ahead and move this down because we could use a little more room. And then we're going to keep going. I'm going to get rid of this guy. Oops. All right. We're going to multiply it by 1/2 again. And I'm just doing this to show you the behavior of the function, what's happening. And you can see it for yourself. So when I do it again, now I'm going to get 1/8, right? And as I keep going, notice I'm multiplying the bottom of this fraction by 2. That makes sense because we multiply fractions, we multiply across. So we're going to do 8 times 2 and 1 times 1. So 1/2 to the 4th is going to be 1/16. Notice what's happening. We're getting smaller and smaller and smaller. What this really means is 1 divided by a number, 1 divided by a number, 1 divided by a number, and that number on the bottom is getting bigger, so we're dividing 1 by more, okay? So I want you to think about this as a cookie. So we've got this cookie, and I want you to think to yourself, I'm taking this one cookie, and I'm dividing among a certain amount of people. So in this first instance, I'm taking one cookie, and I'm dividing among 2 people. So I'll just cut it in half. Well, now in this instance, I'm taking one cookie and dividing it among 4 people. Okay, no problem. I'll cut it in four parts. This, I'm taking one cookie, dividing it among 8 people. All right, I can still do that. Now I'm dividing among 16. Man, that starts getting really hard, right? So I want us to go back here. Notice how small this piece is. And we're going to keep dividing these pieces in half, right? So could I keep doing that? I can. Is it going to be a lot of cookie? Probably not. So you have to keep thinking about this as those x values get bigger. So looking at our graph, as these x values get bigger, notice each person is going to get less of the cookie, right? Now, let's think out theoretically. Let's say that we share this with hundreds of people. This one cookie we're going to share with hundreds of people. Can I divide this cookie into hundreds of pieces? I can. Are they going to be very big? No, they're not. But they are going to be a piece, right? They're not going to be 0. You're never going to get 0 when you divide this cookie into parts, right? Someone's always going to get something, even if it's microscopically small. That's where we see our asymptote. So right here is our asymptote, because as x goes out to infinity, as we get more and more people, right? Our function gets closer and closer to 0. Again, I know it looks like it touches. It doesn't. It doesn't touch this, but it definitely looks that way. And notice these are all outputs, okay? Outputs. So if they're outputs, that means y value. Our y value is never going to equal 0, so the asymptote must have the equation y equals 0. If you want to think about this as what we were talking about, if we went out into infinity, we would have 1 over infinity. That means one cookie divided by infinitely many people, which means it's going to be really, 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 really small. Almost 0, but not. This is the same over here, except backwards, right? So our function's never, ever, 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 ever going to hit y equals 0. But this one's increasing, and that's where it starts approaching 0 is over here. Same thing. Think about 2 to the 0th power, 1. We're going to multiply by 2 when we get bigger. So 2 to the 1st, oops. 2 to the 1st is 2. 2 to the 2nd is 4, right? We're going to get bigger. So to go backwards, we're going to divide by 2. Which means I'm going to take 1, divide by 2. I'm going to get 1/2. This, by the way, is 2 to the negative 1. Divide by 2, 1/4. Ooh, do you see a similar pattern as the one above? You should. These are the same sort of numbers we were getting above. Yeah, I'm just doing the other function, but backwards. All right. So again, as we get smaller and smaller, as our x values get smaller, we are getting closer and closer to 0. Okay. Thank you so much for listening. Have a wonderful day.